there we are. So you have two instructors, and those are names. I now give you, first of all, a general overview of the course and some practical info, and then I will start perhaps with the first topic. So first of all, the idea is that we try to be a bit interactive here. So it means if you have questions, please ask. Just raise your hands and ask. I'm a bit hearing impaired, so you may have to shout, or I will come to you if I don't get what you're saying. If you don't get what I'm saying, just stop me if I speak too fast or whatever, and I will repeat. I'll be happy to repeat. What else? So the idea is that the best approach to the topic, in my opinion, is trying things out. So, of course, we have a reference textbook, other material we'll give to you, and so on. But the best thing to do, I mean, this is no longer, let's say, an undergrad course. So many of the things you can look up for yourselves. There is a lot of information around, better or lower quality. If you try yourselves to see what is going on beyond what we may explain here or what can be written in the textbook, it's a good idea. If you have multiple sources of information, it's welcome. So let's say in an explore-exploit fashion. You try something, you see what you can get out of it, then you look perhaps for new directions and so on. Now, so I begin with a very, very quick tour of the topics we are going to cover in this course. So this course we took up, this course has been going on for quite a few years now, but Andrea and I took up the course last year, and we are in the process of reshaping it a little bit. We started last year, we are continuing this year, and I think the course will stabilize next year. Okay? So I'll try to make a quick tour of what we would like to do this year now. So first of all, what is web information retrieval? Actually, we might begin with, it's a branch of information retrieval. So information retrieval has to do with the analysis and search for information of documental corpora. Okay, so these corpora sometimes, in our case, will mostly happen to be web pages or sometimes multimedia content. But in general, you have a collection of documents. So this might even apply to a collection of newspapers, articles collected in some form, in an electronic form, for example. So, in general, it can be defined. I don't like very much definitions from top down. I normally like to abstract definitions from notions. But let's try to make an exercise in this very first lecture. So, sometimes you're interested to retrieve information from a collection of documents. For example, you have newspapers, articles. You have 1 million newspaper articles, and you would like to collect information, for example, about an oil spill off the coast, of the east coast of the United States. Oil spill, you know? Oil lost from an oil field, for example. And there could be dozens or hundreds of articles about the topic. So essentially, you should have some way to submit a query that specifies what you're interested on, and the system should come up with a suggestion, so a list of articles that might be connected to the topic you're interested in. So we have typically two elements here, a collection of documents and an information need, right? So this is a very general abstract model. So this abstract model also applies to whatever you're doing whenever you query something on Google, for example. That's the very same point. That's the very same problem. You submit a query because you have some information need. The query, in some sense, is the translation of your information need that is here into some more or less well-formed sentence or phrase. And then you have a system trying to retrieve documents that might be of interest to you, web pages in this case. Okay? So, last year, I was mentioning a live example here. What does it mean? Live example. What did I want to say with that? Yeah, live example might be, well, that's our live example. Your information need, set of potentially relevant documents. In the case of Google, also sorted in according to not just relevance, but also something called authority. But we'll come back to that. Okay? That's the idea, the basic idea. This is the basic translation of this in one specific case of a search engine. Now, why is the web different, for example, from a collection of documents, a standard collection of documents represented in digital form, for example, or actually even a collection of documents in paper format in a library? It's the same problem, okay? Only it becomes considerably more difficult to answer a query, I mean, more time consuming. Well, first of all, there is something that is very specific to the web and which was not present in old, let's say, document formats, which is the presence of links, hypertext. So it's called a hypertext. So you have links connecting different web pages or web pages to multimedia content, for example. And this adds actually a further level of information that you can leverage, you can try to exploit. Because, for example, whenever you have one document, one web page pointing to another web page, in some sense, there is an implicit endorsement in the first page. So the authors that wrote down the first page are saying, look, that other web page might be related to the contents of this web page. You see? Is it clear? For example, if I write down an article and add a hyperlink to another article, in some sense I am endorsing the other article. I'm saying, look, this other article might be of interest for you who are reading this one. This is a very important piece of information that actually modern search engines exploit. And that's one reason why the web is different. It's not different intrinsically, it's just it has more information that you can use. Then, the web pages are semi-structured documents. What does it mean? They're not completely structured like in database. It's not they're not just elements of a database with attributes, but they have some structure. For example, they have tags, they have different fields, titles, and so on that can confer different relevance to queries depending on where a certain piece of text appears. For example, in the title, in the main body. Okay, you can exploit this information as well. Why is then the web different again? Because it's evolving. It's constant. Of course, every document collection is evolving in principle. I add a new newspaper article, it's evolving as well, right? But in this case, what we mean by evolving is that in some sense it is changing online under our feet as we speak. That's the difference. It is not changing in a coordinated way. Like, for example, it happens if I add one new newspaper article to a document collection. It is actually changing all the time as new contents is created. Then it also has multiple contents type. Multiple contents type, video, audio, whatever, actually. And currently, it has evolved into also, part of it has evolved into applications that are built on top of the web, but that to some extent have an existence of their own, like social networking platforms, for example. I mean, they are built on top of the web in the end. These are web pages. But there is more to this. There is an application built that, in a way, is creating pages, linking them in a way that is not, that to some extent is let's say, mediated by a platform. Also, which is true for every document corpus, in web information retrieval, a lot of emphasis has been put on the idea that that not all documents were made equal. Even though many people outside computer science faculties seem to think otherwise. So they will pick whatever information they get in the internet and say, ah, you see, this makes my point. It was in the internet. Well, actually, in any serious computer science faculty, we will assume that actually the quality of documents is not so homogeneous. So not all web pages were made equal. Some are more authoritative than others. So the information contained in some sources could be of higher quality than information on the same topic contained in other sources. A very big challenge is to understand, is to filter out high quality documents from the mass of documents. It's a huge mass of documents. We have hundreds of billions of pages now, currently. Not all of them are accessible, but a large fraction is. And in a way, finding good information is sometimes like looking for a needle in a haystack. L'ago nel pagliaio. Yeah? Okay, that's a big challenge. So, in some sense, this is what makes this set of features, this set of actually challenges is what makes the web unique. Of course, if you switch to another source of information, you could come up with different characteristics making it unique. But we are speaking of the web now. So, the web has changed over the years. This is where I started using the web, essentially. Essentially, with the static pages looking very dull, handwritten, HTML, with hyperlink manually added from people, and not too many users. And mostly, the content used to be published. What does it mean? Every web page essentially was meaning one or more people writing the contents and publishing it. So what does it mean here, published content and user-generated content? Because this might look a little bit contradictory at first. Because in the end, I've just said people were generating web pages. So here we are making a distinction of roles in people running some activity and building websites for that reason and people using the websites. This is what I mean by users. In most cases, this picture is telling us that most web contents was generated by people building websites, and very little was generated by the interaction of users using the websites. Okay? Today, the picture is actually, I don't want to say reversed, but it looks much more symmetrical. If you just trivially, social networking platforms contribute to a lot of the existing web pages, right? And a lot of the contents, of their contents is user-generated. The very moment you add a post, the very moment you add a like, you are changing the web, right? And that is user-generated content. At the same time, Facebook is also changing it. Whenever you get a new recommendation for something you might be interested in, that is a tiny piece of the web that is being changed by Facebook this time. But let's say that this ratio here has become more balanced over the years. And this was the picture in 2006, more or less. So, this is just a number of buzzwords that I found around, okay? But what is the meaning of it? Well, before it was mostly about reading individual users. Sometimes you would have a taxonomy. What does it mean, a taxonomy? An organization of web pages according to contents in order to best address them. You would have a large presence of what were called portals. So web pages, web directories in some sense, that you should help you find your way in the web down to the topics, to the web pages you're really interested in. Now, this function actually is mediated by web search engines, for example. And now you have new ways of using the web that also reflect the fact that a lot of it is user-generated content. For example, if you think of blogs, that still exist, actually. So this is user-generated content in the sense that a blog user is someone using a blog, some server, blog platform, and changing it over time. Okay, then you have ideas of sharing. Sharing what? Information. I mean, you have this sharing icon in your phone, right? Half of the time, correct? Yeah, that's sharing. Then you have some buzzwords. You find the news find you. Ah, great. What does it mean? You might find this article interesting. That is what it means. The news find you, okay? And that's called recommendation. And so on. I'm going to skim a little bit over the slides, okay? So, the course outline. So we'll try to follow the main steps that you have when you want to build a web corpus and use it to, for example, answer queries. Now, what should I do? Well, first of all, you have to collect a web corpus. Collect means crawling the web, downloading web pages. Then you should organize your corpus. The moment you download, the moment Google downloads a corpus of web pages, actually, which it is doing constantly over time, also now as we speak, you have a huge amount of web pages growing over time, if you don't throw away older pages. And you have to pre-process this web corpus because, if you look at a web page, what do I mean by pre-processing? Let me see if this is easy or it has become hard. Where is it? I do not have my... I do not have my goggles with me, and I do not see very well at the moment. Okay, I'll show you next time. It is not that important now. But anyway, if you have a web page is essentially an HTML document plus satellite information, plus contents that is loaded by the page, by the browser when you open the page. So you have to download for every web page all this stuff, and then you have to pre-process it. Why? Well, if I want to answer a query, for example, I want to return the addresses of web pages that might be interesting to a given query. Well, I have to pre-process the pages, right? I have to know what is the text present in the page. I have to know which the hyperlinks it points to. I have to give a score to the page. What does it mean? How authoritative, how high quality, how good is the quality of the information contained in this page, and so on. That's called, let's say, pre-processing. Then you have to organize your data in such a way that it can be efficiently queried. What do I mean by efficiently queried? I mean this. This little number here. Okay, 0.41 seconds. So one thing that is pretty well known is that users are not very patient, like kids. We are like kids. If I have to wait for 2 seconds to get a page of results, I skip to some different search engine probably. So I want good results and I want them to be provided fast. So you have to organize a huge amount of data. We are speaking of gigabytes and gigabytes, many, hundreds of gigabytes of data in such a way that queries can be answered quick. Okay? And let me see. Yeah, for example, in this case, apparently, according to Google, there were more than 10 million pages relevant to this result, out of 100 billion pages or so. Okay? Remember, less than half a second. How do you do that? Also, another thing we are going to look at, so these are the main steps of providing information over web corpus. But then, how can we use the web to provide additional services, sometimes for ourselves, more than for the users? So this is, let's say, the central part of the course. But then there are other interesting parts, in my opinion. For example, if nowadays we want to be aware of what is going on in this world, in this complicated and messy world, maybe we should also understand what is going on here. For example, how our information is being used by third parties, you know? For example, we should be aware that there is a lot of money moving on the web. For example, what is Google living out of? How is Facebook living? I mean, maintaining Facebook is very, very expensive, but you don't pay, you pay zero for Facebook, right? So, where do they get the money from? From water? How do they do that? Probably it has to do with information. So, more about that in the future, of course. We leave the questions now. So first of all, how will I collect a web corpus? Oh, well, actually, so this is a very quick tour of the course, okay? The entire course, or almost, most of the course concentrated in 1 hour, more or less. So a very simplified scheme is that you use the link structure of the web. So whenever you want a page, you just, you know, HTTP, you studied this, HTTP, right? You ask an HTTP, you present an HTTP request for a page, you get a page. That's the basic step. Once you get the page, you can actually parse the page, look for hyperlinks, and then you observe the link structure of the web. So, in principle, for every link, you ask a new HTTP request, and you collect a page. Yeah? Now, if you think about this problem, if you think about this, it's actually, it looks simple. But if you think about, it is exploring a graph. Do you agree with this? Yes or no? Who doesn't agree? Who wants to ask the question, where is the graph? I don't see the graph. Do you see a graph or not? If yes, who are the vertices? I told you, I'm hearing impaired. Who are the vertices of the graph?
The web pages.
Web pages are the vertices, and directed links are the hyperlinks, right? So you have a graph. Essentially, you're exploring the graph. So the main difference with what you have seen in your undergrad courses is that normally you assume you have the entire graph, right? Here you haven't the entire graph. So you're visiting a graph, but you don't see the entire graph. So when this is the case, you have a number of troubles, potentially. For example, when am I going to finish? Easy, you're not going to finish. And then you have other problems that you also have when you visit a standard graph. I'm visiting a graph, I don't want to visit the same page twice. Or perhaps I want to, but not soon. Eventually I want to revisit a page because perhaps the page has changed, right? But I do not want to do this too soon. So in a way, you have to visit a graph. The standard problem you saw in, what is it, Fondamenti 2 or so, I guess. Yeah, you said, oh, how boring. Yes, very boring, but apparently useful. So you had to visit this graph. While you visit the graph, you download the information associated to the vertices and perhaps to the links as well. And you go on. But here comes another problem. If I were just using that machine to do this job, I could. You can do the job. Well, of course, I would run out of memory at some point. I mean, my disk would get full at some point, pretty soon. But there is another problem. It would be incredibly slow. I cannot afford exploring the web in 100 years. That takes too long. So what can you do? Well, of course, you can use powerful machine, but perhaps you should also use many machines in parallel, right? That concurrently explore the web. But when you do this, you have other problems. Because perhaps 2 different clients are visiting the same portions of the web graph, right? You see the problem? It causes conflicts. So I have overlapping portions of the graphs which I am downloading, and I may have the same information several times. How can I arrange this? That's a secret. No, it's not. But there is ways to do it. I just wanted to give you an idea of the type of problems you face when you want to do this stuff. Okay, in principle, it's relatively simple things and algorithms you have to do. Not always, but very often it's simple stuff you want to do. But it becomes very, very hard pretty soon because the data is very large and because very often you do things concurrently. Okay, and efficiency is a premium. You want to be fast. Example. What was the example supposed to be? My God. Oh, get started. AP5. So essentially, this is web scraping. So this is for you. I'll not go on with this for the moment. But you go to this web page. Essentially, it allows you to download a portion of the web. Okay? Yeah. You sign up, you create an account, and essentially this will start downloading web pages for you. You give, for example, an initial address, and it will collect the entire page or a set of pages and so on. It's nice, I mean, to try, to see what you get. You will see soon that the amount of bytes that you get grows quickly fast. Okay? So, crawling, we were saying. Crawling is the task of collecting a web corpus. So, crawling the web, traversing web links, visiting the web pages, downloading them, and collecting this information. So you have to remember to keep track of the pages you collected, so the textual information, and the link structure. You need both, okay? Because you will be using it. Yeah, at this point, I don't expect most of you to have completely understood what I said, because otherwise you would not be here, right? So it's fine. I'm just going over very quickly. So just be aware that this is not very easy. Another point that is making things harder is that actually the web is 100 billion. I mean, you're not going to really crawl the entire web. Very often every search engine will crawl a large part of it, which means that something is left out. So since you want to return stuff that is accurate with respect to the information need of the users, you don't want to leave important things out, right? So you don't want to forget about important pages. So this adds an additional dimension of challenge to the problem. How do I avoid leaving important things out? Well, that's a hard problem, and very often you will have bias in the data, which means that essentially the portion of the web you have is not really representative of the entire web, but it is a sample collected in some way. Actually, the type of visit, it is proven that the type of visit, for example, BFS or DFS, that you consider actually affects the bias. So when you choose which type of search to perform, normally it is BFS, you should be aware that this is going to produce a bias. For example, which means that not all nodes have the same probability of being sampled, for example. Now, web applications. This poses a challenge for crawling because perhaps you know already. Have you ever tried to download web pages from Twitter or Facebook for some reason? You can. There are APIs to download pages taken from Facebook or Twitter, let's say accounts, usernames or tags. But there are restrictions. For example, it used to be in Facebook that you could only explore a portion of the graph which was, I think, at most 2 hops away from your homepage. And in Twitter, there are restrictions. You cannot, for example, download the entire. If I give a hashtag, I cannot download all the posts that are related to that hashtag. And then there is a total amount of posts you can download, I don't know, over a given period of time, and so on and so forth. Okay, so this, for a web search engine, is a further restriction and problem you have to keep into account. So, okay, we have collected our web corpus in some way, which means that we have a representation of the graph that we have collected, represented in some way, and on top of that, for every vertex, we have all the information. So the text information, metadata, whatever. Well, gigabytes and gigabytes of stuff. And now? So remember that if we think of a search engine now, the final outcome should be this. This is returned using a web corpus. Okay, Google has collected a web corpus. You submit queries. This is the result. These are called snippets, probably you know, and they are obtained from the pages that they have downloaded and scraped. Okay. So how do we achieve this? Well, so first of all, we have a few goals in mind. One is relevance. That is my query, and here, if you look, what is this? It's the book. Actually, this is a book about information retrieval, a university book, an undergrad or graduate course book about information retrieval. So it's a good match for the query, right? So it means that this page is relevant to this query. I want to achieve relevance. At the same time, however, I also want to achieve this. Okay, efficiency. It is well known that when you want to do things in haste, you might lose something in accuracy, right? So you have to, these two things don't agree very much. So you have to combine them in a smart way. How does Google put it? I suggest following this. It's a very high level. Okay, this is half between education, teaching, and advertisement. Google advertising itself. So you take this with a grain of salt, but it provides some interesting information and videos about, at a high level, how they crawl the web, how they index the web. Indexing means organizing the web corpus so that it can be queried, that you can ask queries on the web corpus and efficiently retrieve relevant results. Okay, I suggest just follow the links I give you, and perhaps build new links, find new links yourselves. Okay, it's the more you do, the better. So they distinguish, as we did actually, three major ingredients. One is crawling, which we just saw. Another one is indexing, which we are about to see. And the third one is searching. So crawling is your interaction with the real graph, with the real web. Indexing is how you organize the information you have collected, the web pages you have downloaded. And search is how you find out, how you answer a query on the web corpus that you have here on your servers. So indexing is how you get 0.3 seconds. Okay, to be clear. How do I get 0.3 seconds? Well, that's a challenging task, because the objectives you can consider a lot, and you have trade-offs, as we just saw. If you want relevance, would call for more time to carefully find relevant stuff. Efficiency calls for the opposite. I need something now, good. Perhaps not the best, but of good quality. So one key thing that we are going to look at is what is called an inverted index. This is a data structure that is the core of a modern search engine, and is used to efficiently search the web corpus for relevant documents. Okay? So this is where the keywords you give in your query, so the words you use, web information retrieval, 3 items, web information retrieval, those terms are used to find out the potentially relevant documents. Okay? And here you have the basic problem is relatively simple. In practice, It is a nightmare because there is a number of details you have to keep into account. So where web search engineers have to keep into account, and I don't even want to begin with those. Okay, I have to know a little bit about, but that's of my research. That's the part that I really do away with. Okay. So finally, once you have used this beautiful data, structure to build your to organize your web corpus, you can finally answer queries. How do you answer queries? There is a problem. Think of the following problem as prospective engineers, what you want to become. Actually, you are first undergrad engineers already, right? So you're already engineers. Now, think of the following problem. I have 50 billion documents organized in some way. These 50 billion documents can be relevant for a query or not, right? The same document can be very relevant for a query, but it could be absolutely nonsense for another query, right? If the query is web information retrieval, let's say, I don't know, the Wikipedia page on web information retrieval is absolutely relevant, but if my query were, I don't know, Juventus, I'm not supporting any, that's just the first word that occurred to me, nobody offended. If my query were Juventus, let's say a web page on web information retrieval would be absolutely irrelevant. So that is a first remark we should do. Relevance is query dependent. Relevance is not absolute. So relevance depends on the match between a document and the query. Two things. So in some sense, this is telling us as engineers that the relevance of a document, however we measure relevance, has to be computed online. You see that? When the query is submitted. You cannot pre-compute relevance. You can try to pre-compute whatever you can that is used to compute a relevance score at the end. You see what I mean by this? I mean, if I want to find, mathematically speaking, if I want to find the most relevant document for some query, it is like giving them a score. Whatever the score means, it's a number, even between 0 and 1. Okay? Every document will get a number, and then I return the documents with the highest score. The problem is that to compute the score, I have to keep the query into account. So the relevance is not something that I can compute once and for all. Okay? Unless I compute it for every possible query or for a significant subset of the queries. Sometimes this type of things are done in a form of, it is called query caching. So you have some queries that are more common than others, and you try to have pre-computed relevance scores for those queries. But in general, let's say in general, it will depend on the query. So in general, it is something that you compute at runtime, at least in part. On the other hand, there is something else called authority, and this has to do with the quality of the documents. The quality of a document, in principle, might be something that depends mostly on the document than on the query. For example, a Wikipedia page on something is normally considered something authoritative. Just because Wikipedia is a curated collection, if a Wikipedia entry is not yet trustworthy because it is biased or something, normally there is some note warning the reader that actually this Wikipedia page is still debatable. Okay? So very often it is considered high quality material. In that case, it seems that regardless of the query, there is a notion of authority that has to do with the contents themselves of pages, and which we can take for granted. Perhaps there is it is something that we can pre-compute offline and perhaps use to return documents to users. So I remember when I was a fresh user, so in the end of the 90s, that most search engines, the basic idea was the one I'm giving you, but they were mostly textual. So essentially they would find relevant documents. When the text of the document was containing something that significantly was overlapping with your query, that document would be considered relevance. very often you would get a lot of rubbish. If we were still using textual search engines nowadays, we could not leave. We will only get rubbish, essentially. Okay? Luckily, they no longer are just textual search engines. What did I want to say with this? I wanted to say that when you rank pages, so ranking pages, putting them in a rank, from the most important for this query to the less important, to the least important. So when I'm ranking documents nowadays, I'm using a mixture of relevance, so matching the query contents to the document's contents, and authority. So also the absolute quality of a document is factored in, okay? And that's why you get results that very often make sense. If you just have the patience to go down the Google list for 10 million times for 100 pages of results, the quality of the pages you observe will eventually drop. Okay, so you will get that lot of rubbish eventually that when in the era of only textual search engines was mixed, essentially could appear everywhere. Today, it tends to be in the tail of what you get. Not always, but very often, okay? So, we said, how do we define relevance? There is a number of ways that we are going to see. Meta information can be important. For example, as I was saying, if a text of, if some part of the text of your query appears in the title of a document, that confers the document a higher relevance in general, rather than if it appears scattered in the body. So in the text of the documents. So you can use meta, this is using metadata, knowing that some parts of the document are a title, another part is a header, the header of a paragraph, for example, and then there is the body of the document. You can do link analysis. We will see what this means. And eventually, all this stuff combined gives you a ranking of documents, the order in which they will be shown by Google or another search engine. So the final picture, at a high level, you crawl the web, you store the data, you build an index, so to query them efficiently, and then you have ranking algorithms that work on this, not on that directly, that depend on the query also, and then you have ourselves submitting queries and receiving results. That's the high-level picture. So then there is the web as a platform. At some point, I mean, people were asking, there was an era, you cannot figure that out because you're young. But I remember there was an era in which, an era means 15 years ago, 20 tops, in which people were asking, but how will these people make money out of it? So I remember you had Yahoo, the beautiful Yahoo portals, Yahoo News. How are they going to make money? It is true that many startups, eventually Google. So they had to find what, how should I call it? I mean, they really had to develop, they had a business plan, but they had to develop some idea of the business they wanted to do. So how do you make money? So you are offering services for free. Where does the money come from? It's not a question of being the evil empire, but eventually if you want to have a cluster, if you want to have a data center, you know what a data center is? Google data centers, Amazon data centers, that stuff. That's very expensive. That stuff is very, very expensive. It consumes a lot of power and so on. So, where do you get the money from? In the case of Amazon, you have a basis, so you sell stuff. You perhaps underpay people also. So some money comes in. But in the case of Google, what are you selling to me? Eventually, at some point, Google starts having advertisement. First on the result page. You would have advertisement that were actually depending on you. So the advertisement I would observe would not be the same as you. The pages, the result pages I would observe would not be the same as yours. You would get two different result pages for the same query, depending on who submitted them, where they were submitted from, and so on. That is called personalization. And that is the first key step towards making money. Why? Because now I can, for example, put an advertisement on a result page that advertises a pair of shoes to people who are more likely to buy them. You know, in TV you have advertisement, but that is passive. How should I say? That's generalized advertisement. Everybody gets the same spot, right? So the accuracy in targeting is not very high. I mean, it is just by exhaustion. I'm targeting whoever eventually will collect someone. It's like phishing, you know? You send 100 million, I don't know, 1 million emails with the idea that there is a bunch of people who will probably, just by statistics, get trapped, get tricked. In the case, instead of this stuff, a search engine is implicitly collecting information about your interests by cookies, you know? For example, I know that you are the same person that asked us that query a week ago. So eventually I can collect history information about you, I can profile you, and I can leverage that information to decide which is the best advertisement to show when you ask a query for a certain interest need. That means that eventually the advertiser will have some hope of having people click on the advertisement, which means that you are potentially interested in what I was advertising. And I will start getting some money for that, for every click. A cent, a few cents perhaps. But multiply this millions of times or billions of times. Then the money starts coming in, okay? Then you can connect with other people and forwarding information, profile information, and then the money becomes bigger, not just on Google, but also on any website you visit, right? Your targeted advertisement, targeting you, okay? Not to tell about social networking platforms. That's the same story. Well, that's where mostly the money comes from. Then you can sell computing power, for example, because you have data centers, a lot of power that can be sold. Amazon Web Services, for example. Okay? So we will go a bit more into detail about this in the second part of the course. And today this is the picture just for social networking. I mean, a part of the picture just for social networking. I honestly, I know just a tiny subset of these names, and actually I'm not a big user of social networking platforms myself. I can study them, but I don't choose them. And that's true for many people studying social networking platforms. Many colleagues in web information retrieval don't choose them. Because why? I don't know why. But we study them. Okay? Anyway, there is a number of them now. And all of them are very nice platforms to sell ads. Okay? So that's a good part of the money Facebook makes. Advertisement eventually, selling stuff. I mean, they have to live out of something. Okay? So, what has changed and which are the new challenges? That's other things that can be of interest. For example, in the case of search engines, people have been looking at, okay, can we combine the results of different search engines to provide better results? Makes sense. This is called meta search. There are a few meta search. Actually, there was a meta search engine called meta search. And this poses a number of challenges because systems are different. Perhaps the web corpora they're considering are different. Perhaps they are using different ranking algorithms. So how do I best combine the results of different search engines? For example, this was just to show you that you can come up with very interesting research problems just by asking very simple questions. You know? This is a simple idea. And yet, it brings with itself a lot of interesting problems. And this is a famous personalization I was talking about. These two different web pages associated to the very same query. Okay? So you have book results, but depending on how submitted this query, the results can be different. And why? Profile. It means the following. You try to download your Google data or YouTube data at some point. You can download them. They will give it. You will get a lot of data. Okay, depending on how much you use it. This can be a lot of data, but you will see your data, and you will discover, you'll go over your life of the past, I don't know, 1 year, and remember, oh, yes, I had forgotten this, but they have forgotten nothing. Okay, so it's all there, all the queries you submitted. Very often you do not need to be authenticated. You can be a Google user, but you don't need to be a Google user, because you can use cookies. Yeah, you get an ID, and they don't care who you are, actually. They just care to know that you are the same user that submitted that query 1 month ago. Okay? In this sense, it's not yet the big brother. I mean, they don't care who you are, really. They just want to match you to different queries that have been submitted along the time. Okay? This makes the picture even a bit scarier in some cases, but it's not don't take it personal. It's just your profile. It's just money. Okay? No, I'm kidding. I'm kidding here. So, and then let's come to another part. I would like to spend perhaps one lecture on this topic that can be useful also for other courses, which is called recommendations. When we talk about profile, essentially we are talking about the following. If I have a person that has liked these things in the past, how likely is this person to like this thing in the future? For example, you are interested in a mixture of science fiction and, I don't know, art, or whatever, random topics. And you have bought a collection of books on Amazon. Based on that data, can Amazon successfully recommend to you a new title that you are likely to buy? That's a very simple problem. I mean, very simple question, not a very simple problem. Is it clear? So Amazon wants to maximize revenue. So whenever you open your Amazon webpage, you will see a number of titles that are thought for you, based on what you bought in the past. Sometimes they even give you some, let's say, some general information about why they are recommending you some stuff. Sometimes they say, we are recommending this because you bought this, this, and this. They don't say, they will never say how they combine that information, of course. That means revealing the algorithm, which is top secret. But more or less, we have an idea of how they do this, okay? So that is called recommendation. And this is a very important algorithmic component of the online advertising market. Okay? How I, for example, recommend you a new contact on Facebook, how I recommend you a hashtag on Twitter, or how I recommend you that pair of shoes, and so on. Okay? Let me see if I have advertising today, because sometimes I have, and it's very funny. Here, for example, the American, no, today they are harmless. But if I do buy anything on Amazon, eventually on this web page, which apparently is pretty much unrelated, you know, a science sort of newsletter. I mean, it's whenever I buy something on Amazon, it's likely that I get something related here. So a targeted advertisement on this web page, so which is funny. So what are the, and this is one of those pictures that people in business like a lot. What is going to happen in the next 5 years? This is what they were thinking, I think, a couple of years ago. This thing is going to change in the next 2 years. So don't take them too seriously. But this just gives you an idea of what people think are going to be the main trends in the coming years. Okay? So, for example, this is definitely already a reality, right? Most people are connecting through mobile applications. And so all the things I was telling you about have to be tailored for a largely mobile market.